Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion how you can be able to work out questions to do with connected rate of change and small approximations. Number one here, we are told that the volume V of a sphere of radius r is given by this formula, and the radius r of the sphere increasing at the rate of 0.5 centimeter per second. Find in terms of pi the rate of change of volume of the sphere when the radius is 0.25 centimeters. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. In Proflan YouTube channel, we do matters physics and math. So if you are A-level student, O-level student taking CIE and the DEXEL, this is a place for you. Consider subscribing so that when I'll be uploading more tutorials, you'll be notified, and also it will be another way of supporting the channel to grow. So focusing back to the question that we are given here, we are supposed to find in terms of pi the rate of change of the sphere when the radius is this. Number one, we are going to work out what are we given in this question. What are we given? Number one, we are given rate of increase. So we have dr dt, and our dr dt is this value that we have at this point. So our dr dt is 0.5 centimeter per second. Then from the formula that we have here, we can be able to find dv dr. So if we differentiate this, we're going to have dv dr, and in this case we are going to take the power down. 3, we are going to take it and multiply to 4/3, and then that is going to reduce to 4 pi r power 2, because when you differentiate, you take the power down, you decrease the power by 1. So we have our dvdr at that given point. But you see, we are told we're working out our value when r is 0.25. But the question is, we need to find the rate of change of volume. So meaning that we are trying to work out dv dt. Right? Now, to find dv dt, we're going to say that dv dt can be obtained from dv dr times dr dt. Because if you see that if we can cancel this and 2, we're going to remain with dv dt. So meaning that we can now work out our dv dt by writing what's our dv dr. dv dr. Our dv dr is here, which is 4 pi r squared times our dr dt. We had it as 0.5, that, and then because we are finding our dv dt when r is 0.25, then we are going to say this is going to be 4 pi into 0.25 squared times 0.5. And if you can work out using your calculator, and you're gonna leave your answer in terms of pi, we are going to get our answer as 0.125 pi, and that is going to be our rate of change for volume. The next part we are going to look at is small increment and approximation. Whenever you see a question like this, and we are going to use question number 2 to focus into that, we are told that it's given that y is tan 3x sine x. Find the exact value of dy dx. So meaning we need to differentiate this, and whenever you have an expression like this, you can see now this expression is 2 functions which are divided, then we can be able to use what we call quotient rule. And from quotient rule, you can say using quotient rule. And quotient rule states that if we have two functions divided, suppose we have u over v, two function divided like that, to get the gradient function, yeah, I mean to differentiate this, we're going to say this is going to be v du dx minus u dv dx divided by v squared. So of course we can now say the top function here is u and the bottom function or the denominator is our v, because in this formula we need to know what our du dx is, we need to know what our dv dx is, which means we're going to differentiate tan 3x and we're going also to differentiate sine x. Now because we have identified that our u is equal to tan 3x, then I want you to find du dx. Basically, this is two functions here. We have tan 3x and then we have 3x. So meaning these are two functions. So we are going to use chain rule to differentiate this. And we start by differentiating the inner function. And the inner function is 3x. If you are differentiating 3x, you're going to get what? You're going to get 3. So we're going to get 3. Okay? Right? If you differentiate the inner function, and the inner function is actually 3x. So if you differentiate 3x, what do you get? You are going to get 3. The next thing we're going to do, because this was chain function, again now we're going to differentiate the tan without looking at 3x. When you differentiate a tan, what do you get? You are going to get sec squared 3x. So the point is, when you are using chain rule, when there are two or more functions together, you'll differentiate the first function you can see, write it down, then you differentiate the second function without considering what's inside here, and you multiply the two. Then also we have our v. We have our v, and our v is equals to sine x, and dv dx is equals to cos x. So if you differentiate sine x, you are going to get cos x. Now what we did here, or what we have done here, is just to prepare so that we can be able to plug in this function into the gradient function, yeah, into quotient rule, because now when we shall be having v, we shall write what v is, then we are going to, next to it, we are going to multiply the u dx, and we shall be writing u here, and our u is tan 3x times dv dx, and our dv dx now we have already gotten it here, and the u dx already we have it at this. So we can go ahead and say what our dy dx is. So we can be able to say this expression can be written as 3 sec squared 3x sine x minus cos x tan 3x, and everything divided by sine x raised to power 2, that is squared. So once we have this, because we are told we are supposed to find the exact value of dy dx when x equals to pi over 3. So meaning that we are evaluating gradient dy dx where at x is equals to pi over 3. So we are going to substitute into this expression. And what you need to remember, a calculator doesn't have sec. And sec is the same as 1 over cos. So whenever we're going to put this in our calculator, we're going to say 1 over cos. This is 3x here. So it will be 3 times pi over 3, and that is going to be pi. Everything now is going to be squared because this sec was squared. Then that is multiplied to sine pi over 3. We are going to put that in the calculator as well. And then minus cos pi over 3 tan pi. Then everything is divided by sine pi over 3. Then you square that. That's how you're gonna put it in your calculator for you to get the answer. Now, if I put this in my calculator, I'm going to get my value at the end. My value is going to be equivalent to, if I put it in my calculator, my value is going to reduce to this. Let me just translate this. This is going to be 3 root 3 over 2 minus 1 over 2 times 0, because this part will be 1 over 2 and this is going to run to 0, and I divide everything by root 3 over 2. And if I square this and calculating and try to solve everything that I'm having here, I'm going to have my final answer as 2 root 3. 2 root 3. Because we are supposed to find the exact value, so that's why I'm leaving my answer in sad form. Then we're told, hence find the approximate change in y. We are finding the approximate change in y. So whenever you are asked a question like this, approximate change in y, let me just tell you a shortcut. This is going to be approximate change in y. This is the shortcut. If you have worked out dy dx at this value here, at which value? At x is equals to pi over 3. And that is exactly what we have gotten here. If you are working out the approximate change in y at this point, pi on 3, and they are asking you, what is the approximate change in y as x increases from pi over 3 to pi over 3 plus h? Basically, the answer you got here as dy dx when x is pi over 3, just multiply h, this value that they are giving you here. If that value that they are writing here is p, you are going to multiply by p. Dy dx at x pi over 3 times the variable they are giving you here. So that is equivalent to, we have worked out what our dy dx is when x equals to pi over 3. We have worked out the value of dy dx when x equals to pi over 3. Then now at this point we are going to write it the way it is. We are going to write 2 root 3 times h, and basically finally our final answer becomes 2 root 3 h. That is the approximate change in y. So Now this is another beautiful question, whereby we are supposed to show our prowess of rate of change. Now, this is another interesting question. We are told that dx dt is equals to 3 units per second, because we are given increasing rate of change, x increasing 3 units per second. So this is dx dt, and already we have dy dx. Already we have dy dx. We have worked out dy dx, and our dy dx is this, yeah, which is equals to 2 root 3. Then we are asked to find, we are supposed to find what? We are supposed to find dy dt is what? We are asked to find dy dt. That's what we are finding. Now, at this point of time, we are going to say that whatever that we're being asked, dy dt can be obtained from dy dx times dx dt. Because at this point, if you see here, if can cancel this, if you can cancel this guy and this guy, you are going to remain with the y dt, which is the part that is on the left hand side, which is the y dt. So meaning that to find the y dt, we are going to get the value of the y dx, and the y dx is 2 root 3, right? And times the value of dx dt. Our dx dt is 3 units per second. So this is going to be 3. If you multiply the two, what are you going to get? We are going to get 6 root 3. Our final answer. If you got value from this particular video, consider subscribing so that anytime we're going to upload a tutorial, you'll be notified. See you in the next video.